Good morning, sir. My name is Srinath Kumar. I am from ECE. Today's my topic is pulse amplitude modulation. My roll number is 234G1A04B3. Pulse amplitude modulation. In pulse amplitude modulation, we will discuss about generation characteristics and applications. Introduction to PAM. Pulse amplitude modulation is a form of modulation where the amplitude of discrete pulses is varied in accordance with the amplitude of the analog signal. PAM is widely used in the telecommunication and data transmission in its simplicity and ease of implementation. Basic principle of PAM. PAM involves taking an analog signal and sampling it at regular intervals to, to produce discrete pulses amplitudes. The amplitude of the each pulse corresponds to instantaneous amplitude of the sampled signal. This representation allows for efficient transmission of information while maintaining the integrity of the original signal. Generation of PAM. PAM signals are generally generated using a sampler that samples the analog signal at specific intervals. After sampling, a pulse generation generator creates rectangular pulses whose amplitude correspond to the sample values. The resulting PAM signal can be filtered and shaped to reduce in spectral width and intersymbol interface. Characteristics of PAM. One of the key characteristics of PAM is its ability to represent an analog signal with an infinite number of discrete levels. PAM is sensitive to noise and the signal quality can degrade significantly in the presence of interface. The bandwidth required for PAM transmission is directly related to the sampling frequency and the number of amplitude levels used. Types of PAM. There are two types of PAM: single level PAM and multi level PAM. Single level PAM uses two amplitude levels to represent binary data, while multi level PAM can represent multiple bits per symbol. Multi level PAM can significantly increase rates, but the cost of increased complexity and sustainability to noise. PAM is relatively sampled to the implement, making it a preferred choice for basic communication system. It can be efficiently utilize bandwidth, especially when combined with advanced encoding techniques. The ability to easily convert PAM signal to digital form of enhances capability with modern digital communication technique systems. Disadvantages of PAM. PAM is more susceptibility to noise and distortion compared to the other modulation schemes, limiting its effectiveness in noise environments. The increase in the number of amplitude levels can complicate receiver design and increase the potential for errors. PAM signal required adequate filtering to minimize inter-symbol interface, which can be complicate system design. Applications of PAM. PAM is commonly used in baseband transmission systems such as Internet and other local networks. It is also employed in the digital audio processing where it can represent audio signals in the manageable format. Other applications include pulse code modulation systems and various form of signals processing in telecommunication. PAM in modern communication. PAM is integrated into modern digital communication systems, often serving as a building block for more complex schemes. It plays a crucial role in applications like digital subscriber lines DSL and pulse amplitude modulation in wireless systems. The development of high-speed PAM systems are enabled advertisements in broadband communication technologies. Future of PAM. The evolution of PAM continues with the research into higher level PAM schemes. that can deliver faster data rates. Innovations in signal processing and error correction and addressing the weakness of PAM in a noisy environment. As communication system demands higher efficiency, PAM will likely adapt and remain relevant in the future technologies. Thank you.